In this exercise we have an infinite series, we can see because the sum goes to infinity, and we have to determine if it's convergent or divergent. There's more than one way to do this, but here we'll do it using what is called the comparison test, which is summarized here, which basically says that if, when we're talking about positive or non-negative series, that if we are less than a convergent series, then we're also convergent. And the logical consequence is that if something is bigger than a divergent series, then it diverges. But before we start doing anything formally, we have to decide which of the two cases we're aiming for. And we use some vague techniques just to at least decide whether we're going to try for convergent or divergent and then do it more formally. So let's see. Roughly speaking, with polynomials, rational functions, what really counts are the leading terms. And in general, this series behaves like, I'll write that using a squiggly line, behaves like the leading terms, which is 5n squared over 14n to the fifth. I forgot the sigma. N from 1 to infinity. And constants don't really matter. You can sort of ignore the 5 and the 14, and this behaves like n squared over n to the fifth. It behaves like 1 over n cubed. I say behaves like, I mean it converges like. If this converges, and vice versa. And we throw constants and other stuff out,